Hello guys, in the last session we have solved the centripetal force problem with the help of Lagrangian mechanics. In this we are going to solve the simple pendulum problem which is moving in a vertical plane. Okay, so we are going to take polar coordinates and we are going to find out the equation of motion with the help of the Lagrangian mechanics. So now you know that we are going to take polar coordinates, that means r and theta. Here r is equal to L, which is equal to constant. Okay, so that means r dot is equal to 0. What is the kinetic energy in terms of the polar coordinates? In terms of the polar coordinates, kinetic energy is equal to half m r dot square plus r theta dot square. But here r is equal to L and r dot is equal to 0. So we are going to get the kinetic energy half m L square theta dot square. Okay. So for the Lagrangian we have to find out the kinetic energy as well as the potential energy. So now from the diagram let's try to calculate the potential energy. So we are going to take this as the reference point for the potential energy. So what is the height? That means this mass is at, let us suppose, at height h from this point. Okay, and we have to find out this h, as we know that this is equal to L. Okay, and this one, if this is perpendicular, so this one is equal to L cos of theta. So this height is nothing but L minus L cos of theta. Okay, and as we know that the potential energy is equal to mgh, so that is why mg h is equal to L minus mg L cos of theta, or we can write it as this is equal to mg L common outside 1 minus cos of theta. Okay, so we have calculated the potential energy and also we have calculated the value of the kinetic energy, so that we can easily define the Lagrangian, which is nothing but L is equal to kinetic energy minus potential energy. Kinetic energy is equal to half m L square theta dot square minus mg L 1 minus cos of theta. Okay, so now we know that for the Lagrangian equation what we have dt dl by curly theta dot minus curly L by curly theta, that is equal to 0. So first we are going to find out this and then we are going to find out this. Let's see what is the value of curly L by curly theta dot. Curly L by curly theta dot is nothing but m L square theta dot, because as we know that in the differentiation this 2 comes here and we get 2 minus 1, so that is equal to ml square theta dot. Okay, that's what I have written here. Okay, so now we have to do d by dt for this, and this becomes theta double dot. Okay, and now we have to find out dl by d theta. So dl by d theta, that is equal to, we have only one term with respect to theta here, so you can see that it has this term. Okay, so this is nothing but we can say minus mgl and minus one derivative is 0 and minus cos theta derivative minus of sin theta. So that means it is going to give us minus mgl sin theta. This negative cancels with this, so we get mgl sin theta. So what is the equation we are going to get? So the equation is like this term minus this term. So what is this going to give us? You can see this is going to give us m l square theta double dot minus mgl sin theta, and that is equal to 0. So m common outside will cancel out, and I am going to take L plus G by L, because this is L square and this is L. Okay, G by L sin theta is equal to 0. So this is what the equation we are going to obtain at the end. This is the equation of motion for the simple pendulum in the polar coordinates. Okay, so now what happen if this pendulum going to execute small oscillations? So what happen? Theta double dot plus G by L theta, because sin theta is approximately equal to theta when it is small, when theta is small. Okay, and theta double dot is equal to minus G by L theta. As we know, the simple harmonic motion is what? The simple harmonic motion is like x double dot plus omega square x is equal to 0. So here, by comparing this equation and this equation, we will get the value of omega square. Okay, so the omega square is equal to G by L, and omega is equal to square root of G by L. Here, from here we can also calculate the time period by simply saying that this is equal to 2 pi by time period is equal to square root of G by L, and the time period is nothing but 2 pi square root of L by G. So that solve our problem. So we have calculated the time period, we have calculated the angular frequency, also we have calculated the equation of motion. Okay, so that's all for today. Thank you guys.